evaluate. For these, you're multiplying. Don't forget that they have a denominator of 1. So you'll multiply the numerators and then multiply the denominators. Same thing for number 5 and number 4. Here you have 52 times 4, and then you're immediately going to divide it by 4. So if you do 52 times 4 and then undo what you just did, you're going to get right back to 52. Twice a thing is 4 more than 6. What is the thing? How do you know? Well, twice a thing is 4 more than 6. These are both numbers and these are variables, so they're already on the same side. Here, we are going to combine like terms. So 6 plus 4 is 10. And over here I have 2x. Our goal is to solve it for that unknown thing. Right now the x is being multiplied by 2. So we can divide by 2 on both sides to undo the multiplication. 2 divided by 2 is 1, so we have 1x. And 10 divided by 2 is 5. So the thing is 5. And how do we know we showed it with algebra? We know 4 more than 6 is 10, and twice a thing, twice 5 is 10. Solve the equation by using tape diagrams, then solve the equation algebraically. Use substitution to check your solution. So we're going to start with tape diagrams. We have 5f is the same size as 30. But 5f, there are 5 of them, so we're going to break them up into 5 parts. Each of these would represent f, so we would have 1, 2, 3, 4, 5f. And then we'd have to figure out, well, what is 30 split into 5 parts? So f goes in each box, and then 6, because 6, 12, 18, 24, 30. So f equals 6. Now for the algebraic piece, we have our variables over here and our numbers over here. We want to remove this number 5, so we undo it by dividing by 5 like you see here. And we have to do it to both sides to keep our equation balanced. 5 divided by 5 is 1f, and 30 divided by 5 is 6. Now we'll substitute to check. Is 5, replace the f with 6. 5 times 6 is 30. Yes, so it is a correct solution. Solve the equation by using tape diagrams, then solve algebraically and use substitution to check your solution. So we'll have 2 tape diagrams, one that represents 3c, and one that's the same size that represents 27. We're going to split this up into 3 C's, and then we'll split this up into 3 parts as well. 27 split into 3 parts is 9. So C is 9. Algebraically, our variables are here and our numbers are here. To undo multiplication, we need division. 3c divided by 3 is 1c, and 27 divided by 3 is 9. Now we'll check to make sure it is correct. Replace the c with the number 9. 3 times 9 is 27, so it is a correct solution. Here we have x divided by 3 equals 27. So instead of multiplying by 3, this time they are dividing by 3, which means our tape diagram setup is going to look slightly different. We have x divided by 3 is 27. So if we want x, we're going to need 3 pieces. So these 3 combined would make x. And if this one box is 27, we would need 27 in each of those boxes, which means x is 81. This would be 1/3, 2/3, 3/3 to make a whole x. 27 plus 27 plus 27 makes 81. Algebraically, to undo division, we multiply both sides by 3, and then we get x equals 81, because this would be 3/3 x, and 3/3 is just 1x. And we substitute to check. Is 81 divided by 3 equal to 27? 3 fits into 8 twice, and 3 fits into 21 7 times. Use the tape diagrams to solve this equation, then do it algebraically and substitute. So here I have p over 5 is the same as 7. In order to get a whole p, I'm going to need 5 of those. So now all of this represents p. And all of these together, that would be 7, 14, 21, 28, 35. Algebraically, the variables are over here, and the numbers are over here. To undo division, we would multiply. We have to do it on both sides to keep our equations balanced. 5 divided by 5 is 1p, and 5 times 7 is 35. If we check, 35 in the place of the p, 35 divided by 5 is 7, so it is a correct solution. Lacey writes a correct equation to represent the measure of the angles in the diagram. A. Solve the equation. Use substitution to check your solution. M is a variable. 180 is a number, so we have those sides designated. To undo 4 times m, we're going to divide by 4 on both sides. 4 divided by 4 is 1, so we have 1m left on this side. Then 180 divided by 4 is 45. Use substitution to check. So 4 times 45, does that come out to 180? 4 times 5 is 20. 4 times 4 is 16, plus 2 more makes 18. So yes. And then it also asks, what does it represent in this situation? It represents the measure of these angles. Lisa's work is shown. What does Lisa do incorrectly? She multiplied by 4. 4m times 4 would be 16m, not 1m. Problem 5. The length of a rectangle is 9 centimeters. The length is 1/3 of the width of the rectangle. So you have the width split into thirds. Scott writes a correct equation for this situation. Solve the equation and use substitution to check. Here's where the variable is. Here's where the numbers should be. So to get rid of this 3 over here, we're going to multiply to undo the division. Remember, a fraction represents division. So W is divided by 3. To undo dividing by 3, we multiply by 3. That gives us 1W. And 9 times 3 is 27. Now let's check. If we replace the W with 27, is 27 split into 3 parts equal to 9? Yes. B asks, what does the solution represent in this situation? The width is 27 centimeters. Scott's work is shown. What does Scott do incorrectly? You see on this side he multiplied by 3 like we did, but over here he divided by 3. So he did not do the same operation on both sides. So his equation is not balanced. You should multiply on both sides. 6. Use substitution to check the solution and solve it. Here I see the variables on this side, so we need all of our numbers to go to the other side. Right now, 2.7 is being multiplied by n, so to undo the multiplication, we're going to use division. Remember, there's a little trick that we can use. If we move the decimal once here, we can move the decimal once here as well to turn this into a whole number divisor. So now I have 27 and 302.4. So my decimal is going to line up here. 27 fits into 30 one time. That leaves us with 3. Then bring down the 2. 27 fits into 32 one time. 12 minus 7 is 5. Bring down the 4. 27 fits into 54 twice. So this says n, because the 2.7's divide out, and 30.24 divided by 2.7 is 11.2. Then we're going to check our solution. It is 30.24 equal to 2.7 times 11.2. We'll do some multiplication on the side to check. 7 times 2 is 14. 7 times 1 plus 1 more is 8. 7 times 1 is 7. Then use a spacer. 2 times 2 is 4. 2 times 1 is 2. 2 times 1 is 2. Add them up. We have 2 decimal places in the question, so we need 1, 2 in our answer, and that is 30.24. Here we have 1/3 times z equals 4/5. So we can divide by 1/3 to get rid of this side, and we have to do the same thing over here. So now I have z is 4/5 divided by 1/3. Remember, when we are dividing fractions, we can leave, change it to multiplication, and then flip the fraction over. Four times 3 is 12. 5 times 1 is 5. Now we're going to check. 1/3, replace the z with 12/5, and see, is that equal to 4/5? Well, 1 times 12 is 12, and 3 times 5 is 15. Is 15 the same as 4/5? Well, let's see, if we reduce this fraction, 12 divided by 3 is 4, and 15 divided by 3 is 5. So yes, 12/5 is a correct solution. For this one, we will divide by 2/3, which is the same as multiplying by the flipped over version. 2/3 divided by 2/3 is 1, so we have 1z. 4/5 times 3/2. Four times 3 is 12. 5 times 2 is 10. So z is 12/10. You could also reduce that. 12 is 6 2's, and 10 is 5 2's. Now let's check our work. Replace the z with 12/10 or 6/5. 2 times 6 is 12. 3 times 5 is 15. And if we reduce this, we do end up with 4/5. So we know that 6/5 is the solution to this equation. That's the end for lesson 20. Check back for more lessons coming soon, and make sure that you have all the work represented in your workbook.